America is sinking, and it's not due to the tariffs. It's due to a geological change. The entire North American continent is slowly sinking. Our next story tells you how our planet's crust is dripping under the Midwest U.S.
Beneath the vast lands of North America, something strange is happening. Scientists have uncovered an ancient process unfolding miles below our feet, a phenomenon that's quietly reshaping the very foundation of the continent. It's slow, silent, and almost invisible, but it's growing. Using cutting-edge imaging and seismic data, researchers have detected a mysterious gap forming deep within the Earth's crust. And as it expands, the question becomes impossible to ignore. Could this be the beginning of a geological transformation no one saw coming? What's really happening under North America? Join us as we explore the growing hole beneath North America and what it could mean. The discovery. It started like most scientific discoveries do, not with a bang, but with a glitch.
From Seth Doane in Italy, some notes from the underground.
In 2023, a team of geophysicists at the University of Texas at Austin noticed something strange while reviewing seismic imaging data taken from deep beneath the Earth's surface. They were studying the ancient North American craton, a geological formation more than 1 billion years old, believed to be one of the most stable and unshakable pieces of Earth's crust. But guess what? What they saw wasn't stability, it was movement. Massive chunks of the lithosphere, the rigid outer shell of the Earth, were slowly peeling away and sinking into the mantle. Almost like thick globs of honey dripping off a spoon, the crust was descending into the depths of the planet. At first, the team questioned the data. Was it an error in the models? A misread of the subsurface conditions? But as more seismic sensors confirmed the readings, one thing became clear. Something very real was happening below North America. Now, this is where you'd want to come closer and pay more attention as it gets even more intriguing from here. This wasn't just a fluke or a minor shift. It was something called cratonic dripping, a process so rare and powerful that it could reshape the interior of a continent over millions of years. Imagine a solid stone foundation suddenly softening at the base, parts of it detaching and falling into the abyss below. That's what scientists believe is happening under portions of the central and western United States. The lithosphere is thinning. The continent is hollowing out, slowly but steadily. And while it may not be a hole in the Hollywood sense, what lies beneath is even more mysterious. Because the very layer that gives the land above its strength is disappearing, and nobody knows exactly how far it will go. To understand how this hole-like anomaly began, we have to go back, and we're talking way back. Millions of years ago, an enormous oceanic tectonic plate, known as the Farallon Plate, was slowly being pushed beneath North America. This process, called subduction, dragged huge slabs of rock into the Earth's mantle.
What makes the subduction zone unique, though, is that on one side of the boundary, we see a particular type of lithosphere or crust, which is called oceanic crust.
But unlike other plates, which tend to break apart and dissolve neatly, the Farallon Plate behaved differently. It didn't fully vanish. Instead, massive remnants of it still exist beneath North America, like ghosts of Earth's past, drifting silently in the dark. And according to scientists, these ancient leftovers are likely what's triggering the current instability. You see, the Farallon Plate is denser than the surrounding mantle. Over time, those dense fragments sink even further, pulling chunks of the surrounding lithosphere down with them. This is what geologists are now calling drip zones, and yes, they're growing. One such zone was identified beneath western North America, particularly in areas like Arizona and New Mexico. Another may lie beneath parts of the central U.S., closer to the Mississippi embayment. These aren't isolated dots. They're spreading regions of subsurface collapse, deep under land people drive over every day. Now you may be wondering how it was discovered. Guess what? The first clues came from something called seismic tomography. Think of it like an ultrasound for the planet. When earthquakes occur, they send shock waves through the Earth. By measuring how fast these waves travel and how they bend through different materials, scientists can create detailed images of what's going on far below the surface. And what they found shocked them. In places where the lithosphere should have been thick and sturdy, it was mysteriously thin. Temperatures were higher than expected. And worst of all, there were massive gaps, as if parts of the Earth's foundation had been scooped out from underneath. These findings were backed by magnetotelluric imaging, which measures how the Earth conducts electrical currents, and gravity surveys. Every method pointed to the same conclusion. Something is missing down there. And it's not staying the same size, it's growing. For decades, geologists assumed that the North American craton, the ancient heart of the continent, was immune to this kind of change. It was supposed to be solid, immovable, eternal. But this discovery flipped that belief on its head. It's rare to catch geology in the act. Most of Earth's major shifts, like mountain building, ocean spreading, or continental drift, happen so slowly that we only see the aftermath, not the motion. But cratonic dripping offers a rare glimpse into an ongoing transformation. And that has scientists both thrilled and uneasy. Because this isn't just a localized event. It's a sign that even the oldest, most stable parts of Earth's crust are not as permanent as we thought. Think about it. We build cities, roads, and entire civilizations on land we assume is unshakable. But if the ground beneath us is gradually sinking into the mantle, even by a few millimeters per year, what does that mean for the future? It may take thousands or even millions of years to see dramatic surface effects. But for scientists watching the data, this is already a tectonic-level surprise. Here's where it gets even more interesting and possibly more urgent. As researchers continued their analysis, they noticed something odd. Other parts of the world are showing similar drip-like behavior. Portions of the lithosphere beneath the Western Pacific, the Andes, and parts of Central Asia appear to be undergoing the same process. Could this be part of a larger planetary pattern? A global rebalancing of Earth's internal layers? No one can say for sure. But one thing is certain. The dripping lithosphere under North America is not an isolated case. It's part of a deeper story, one that scientists are only just beginning to understand. And this, dear viewer, is where the mystery truly begins. If parts of our continent are quietly dissolving into the mantle, if ancient tectonic ghosts are still shaping the land we live on, if even our most stable ground is falling away, then what else is happening beneath us right now that we've yet to uncover? What's under North America? Don't get it twisted. We're not talking about bedrock, soil, or layers we learned about in school. We're talking about what's really beneath the surface, thousands of miles down, where temperatures soar beyond 1,000 degrees and pressure could crush steel like paper. Down there, something extraordinary is unfolding, right now, in real time. And they're located in places where the lithosphere, Earth's outer shell.
The lithosphere is a solid and rigid outer layer of our planet. It includes the crust in the upper part of the mantle that contains rigid rocks.
Was once thought to be solid and unbreakable. So what lies beneath? Imagine the floor of your house gradually separating and drooping downward, just enough that you don't notice at first. That's what's happening beneath parts of North America, only instead of wood and concrete. We're talking about continental crust that's billions of years old, slowly detaching like melted wax dripping off a candle. And the strange part? This isn't a surface-level issue. You could be standing directly above it and never feel a thing. To the naked eye, everything above seems normal. Cities bustle, rivers flow, and roads stretch for miles. But beneath the calm lies a dynamic, shifting underworld, one that we've only recently begun to see. In states like Arizona, New Mexico, and Colorado, scientists found irregular seismic signatures suggesting unusual heat patterns and unexpected rock density. When seismic waves pass through certain areas, They slow down or speed up depending on what's inside. And in these zones, the waves behaved weirdly, slowing down dramatically as they passed through what seemed to be nothing. In geophysics, that's a red flag. These anomalies told scientists that instead of a solid lithospheric base, parts of the continent were becoming softer, thinner, and less defined. And it's not just one isolated zone. Beneath the central U.S., particularly near the Mississippi embayment, a second drip region was identified. It's spreading horizontally and vertically, like a bruise slowly forming beneath the skin. These sinking zones don't just vanish. As they drop, they interact with the surrounding mantle. The hotter they get, the more they melt, creating blobs of partially molten rock that rise, move, or reshape the deep geology of the continent. In some areas, this movement has uplifted the land above, changing elevation over thousands of years. In others, it has weakened the crust enough to allow for small-scale volcanic activity, or in extreme cases, earthquake clusters. What's happening isn't always visible, but it's real, and it's reshaping the deep architecture of North America. Scientists now believe these drip zones could be part of a larger, ongoing recycling process, a kind of continental maintenance system where old, dense rock is peeled off and absorbed into the Earth's interior. That process used to be something we thought only happened in active plate boundaries. But this is happening in the middle of a continent. And that changes everything. One of the biggest shocks in this discovery is the realization that Earth's interior is far more alive than we imagined. Most people think of the planet's interior as fixed. The crust is the crust, the mantle is the mantle, and nothing really changes down there except in volcanoes or earthquakes. But this hole, this slow creeping void in the lithosphere, proves otherwise. It tells us that Earth is constantly adjusting, shedding, shifting, and reshaping itself in ways we barely understand. And if this is happening in what was once considered geologically dead territory, where else could it be occurring? What if similar drip zones are forming beneath other major continents, Africa, Asia, South America, right now? What if we've only scratched the surface? Now here's the part that sends chills down your spine. No one knows exactly how deep these drip zones go. Seismic imaging can only provide so much clarity. What we do know is that these anomalies can stretch from 60 to over 200 kilometers below the surface. Some scientists believe the dripping process might eventually reach the asthenosphere, a semi-fluid layer of the mantle where tectonic motion is born. If the lithosphere keeps thinning and these blobs keep detaching, it could eventually trigger new fault zones, cause shifts in pressure, or even create mantle plumes that push hot rock back toward the surface, leading to long dormant volcanoes awakening or new ones forming entirely. This isn't a doomsday scenario. There are no cities falling into underground voids or oceans swallowing coastlines, but it is a revelation. What lies beneath North America isn't just rock and molten metal, it's history in motion, a living record of the planet's evolution, shedding its old skin to prepare for something new. We know you may be asking, what causes this thinning? Why is the lithosphere detaching? And what do Earth's oldest tectonic ghosts have to do with what's happening beneath us right now? The science behind it. To truly grasp what's happening beneath North America, we need to zoom out, not just in space, but in time. Because what scientists are witnessing isn't random. It's the product of deep Earth processes that have been unfolding for hundreds of millions of years. At the heart of it all is one essential concept: tectonic recycling. It's the planet's way of renewing itself from the inside out. Let's break it down. The Earth's layers, and the Earth isn't one solid rock, it's built in layers. The crust, where we live. The lithosphere, a stiff shell that includes the crust and the uppermost mantle. The asthenosphere, a softer, hotter layer of the mantle just below, where rocks can flow slowly like warm tar. The lithosphere floats on the asthenosphere, but it's not indestructible. Over time, gravity, temperature, and density differences can cause pieces of it to break off and sink. But what's causing it? One of the biggest culprits is density. Over time, the bottom of the lithosphere can become colder and heavier than the hotter, more buoyant mantle beneath it. When that happens, it starts to pull away, like a rock sliding off the edge of a shelf. This is called gravitational instability, and it plays a huge role in cratonic dripping. The deeper parts of the lithosphere are simply too heavy to stay suspended. They peel off and sink, one chunk at a time. These chunks don't dissolve right away. They plunge downward as drips, slow, dense, and massive. And as they fall, the gap they leave behind becomes the hole scientists have identified. Remember that ancient Farallon plate we mentioned earlier? It's not just history, it's still playing a role. For millions of years, the Farallon plate was being shoved beneath North America. Though most of it disappeared into the mantle, some pieces lingered deep underground. These lingering fragments act like a wrecking ball, disturbing the balance of the lithosphere above. Their added weight and strange chemistry contribute to the dripping process, making the surrounding rock more likely to detach. So, in a strange twist, this hole beneath North America might be the final chapter in a tectonic event that started during the time of the dinosaurs. As the lithospheric drips fall, they release heat. This heat changes the chemistry of the surrounding mantle, weakening the remaining crust and making it easier for more material to drip away. It becomes a feedback loop. One drip leads to another, and the thinning accelerates. In some zones, this has already created small pockets of magma. They haven't reached the surface yet. But if enough heat builds up, scientists say volcanic activity in previously quiet areas could emerge. Not massive eruptions, but new heat sources that slowly rewrite the local geology. It's a reminder that even beneath calm landscapes, the Earth is always in motion. But guess what? Dripping lithosphere isn't unheard of. Scientists have seen it before under parts of China, beneath the Andes in South America, and in parts of the Mediterranean. But what makes the North American case unique is its location. These processes typically happen at tectonic boundaries where plates collide or pull apart. North America's interior, especially the craton, was always considered too old and too stable for something like this to occur. This discovery changes that belief. It shows that even the most ancient parts of Earth's surface are not immune to change. Even they can evolve, collapse, and regenerate from within. So, what does this mean for us? Do scientists believe it could affect our lives on the surface? Right now, scientists aren't raising alarms about catastrophe. This isn't Yellowstone. It's not about explosive danger. It's about geological evolution.
Scientists have discovered that over 86,000 earthquakes took place under Yellowstone National Park in the United States over a period of 15 years.
The growing hole under North America isn't a threat to human life today, but it could reshape how we plan for the future. In fact, some bold theories suggest that North America could one day tear along this weakness, splitting apart in the distant future. That's purely speculative for now, but history reminds us the Atlantic Ocean itself was once a crack between two landmasses. Meanwhile, NASA's Earth Observatory and other satellite programs continue to monitor the affected zone from space. Their data shows micro-movements in the crust, shifts so subtle they're invisible to us, yet deeply telling for geologists. These movements could influence how we build infrastructure, assess disaster risks, and plan for the unexpected. In the longer term, this could even tie into the breakup and reassembly of supercontinents. Yes, that's right. These drips might be a clue to Earth's next continental reshuffling, millions of years from now. The Carolina case might just be the beginning. But now that scientists know what to look for, they've started scanning other stable-looking regions, places like the western U.S., parts of Canada, and even inland Europe, for similar patterns. The idea that continental interiors are alive and changing challenges everything we once believed about tectonic behavior. And it all started with a drip. But what could happen if the drip continues? You see, Earth's outer shell, the lithosphere, is what continents rest on. When parts of it start sinking into the hotter, softer mantle, it's not just an academic concern. It could eventually reshape the surface geography of an entire region. Even now, parts of the southwestern U.S. are being closely monitored for these subtle changes. The cost of ignoring them could be devastating in the future, especially for communities that depend on stable geology for survival. And interestingly, similar drips have been detected under parts of South America, Asia, and even Europe. But the North American case is especially well studied, thanks to advanced imaging and decades of geological mapping. Also, in parts of Africa, scientists have documented the East African Rift, a massive tear in the continent's surface that may one day divide it into two separate land masses. In Antarctica, researchers have detected mantle anomalies similar to those under the western U.S., raising eyebrows and deepening the mystery. Could these be connected? But even more surprising is the fact that seismic data from Asia and Europe has revealed minor zones of lithospheric thinning, too small to cause alarm yet, but mysteriously similar in pattern. In other words, this isn't just a North American issue. It's a planetary one, suggesting this may be part of a global pattern that's been unfolding quietly beneath our feet for millions of years. As unsettling as the hole beneath North America may seem, it's only one part of a much larger geological mystery. We often think of the ground beneath us as stable, solid, and unchanging. But the truth is, it's dynamic. It breathes, it bends, and sometimes it breaks. It reminds us that science doesn't always offer instant answers. Sometimes it opens up deeper questions. And that's exactly what makes this discovery so powerful. We've come to the end of the video. What do you think about the growing hole in North America and some other places we mentioned? Share your thoughts with us in the comments section. Don't forget to like, share, and subscribe for more. Also, click on the following video showing on your screen. You will enjoy it.